Welcome to video 4 in this MLB workbook series. This will deal with linear regression, and by the end of the video we'll be predicting from our own formulas. Recommend that you watch the previous video, video 3, because it does build on the subject matter there. Okay. To keep this video to a reasonable length, I'm not going to make it an academic treatise or a how-to for linear regression. So I recommend, if you have no idea what linear regression is, you start to watch some videos on YouTube about linear regression with Excel, because that will help you more readily understand what we're doing here. So without further ado, let's go to the workbook. Okay, the first thing we need to do is we need to make sure that we have the data analysis tool pack loaded. If you don't, then just go to File, Options, Add-ins. There it is, Add-ins. Excel add-ins, go, and just hit select the analysis toolpack. You might have to restart after you do that, and then what will happen is you will see data analysis come up under the data ribbon. So okay, first of all, we need a source of data to analyze. So let's go to the estimator, go to machine learning. The historical data is updated every day, and it goes back about 60 or so days. I've already updated it. This takes a few seconds, so let's just view what comes downloaded from the API. Now, this is the data set. Starts around 21st of April, goes all the way through to yesterday. So this is almost 13,000 records, and the way to understand this is that the most important thing is the whole idea behind linear regression is to predict something that will happen in the future based on data you have available today. Simply put, every column of this sheet represents an item of data. The only one that is not available on the day, and the day is represented by a row, is the FanDuel points. So to put that another way, let's just take anywhere in the middle of the data set here. Francisco Lindor played a game on May the 18th. Before the game, we knew certain facts about him. We knew who he played for, we knew his position, we knew how many games he'd played, we knew his hitting habits, we knew we could quantify the type of park he was about to play in. The Vegas betting lines had certain predictions about how the game would perform. We knew everything, even we knew his FanDuel moving average fantasy points over the long term. What we did not know, the only thing we did not know about this particular guy, was the FanDuel points that he would be scoring in the game. So the whole purpose of this exercise is to use all these X components, as they're called in linear regression, to predict this Y component. So at this time, before this game was about to be played against the New York Yankees, we knew everything here, but we did not know what the outcome of the game would be. I stress that point because it has caused some confusion in the past. What I like to do is, once I have the historical data download, I move or copy it to a blank sheet. It's just a thing I like to do. And so now I've got it in book 1. I can save that for whatever I need. I always keep the help file or the function help handy in case I need to find out what I need of a specific data column. So right, we've got our data now. Now we're going to start looking at linear regressions. Okay, just to move things along, I paused the video there, and what I did was I just moved the FanDuel actual points for the match into that column because that's going to be our Y in the linear regression. I also split this sheet into pitchers and hitters. You can do that quite simply by just going into the filter here and selecting just, for example, anything but pitchers, and then copying it over to the hitter sheet and doing the opposite for the pitchers. But I just wanted to move it along a bit. So now the reason I split into pitchers and hitters is as follows. Take a look at this slide. This shows the FanDuel scoring structure for awarding fantasy points. So you notice immediately that the hitter and the pitchers are awarded points using a different scale. For example, the pitchers get 6 points for a win. When the opposition scores runs against them, then it costs them 3 points every time. Whereas the hitters, it just seems to be basically the more runs the team scores, the better off they do. So that's why we've split them up. Now back to the data. Let's start with the hitters, and we're going to start. Let's just make some space here to put our X arguments in. We're going to start with the basic default position, and that's the one in the FanDuel data file. We're going to take the 30-day or greater moving average, and we're going to use that to run our first analysis. So here we go. Data analysis, regression. So the Y value is there. The X value with label, notice the label at the top, is there. So we've got labels, and our constant is 0. Let me just hit that, and then we'll discuss constant equals 0. Alright, so let me just switch to a slide. Okay, so constant equals 0 basically means that the linear relationship we're about to establish runs through the origin, where x equals 0, y equals 0. So I believe that if a player doesn't play, he scores 0 points. So that's why I essentially think that there should be no constant. This is the constant value here, where the relationship, the graphical relationship, crosses the y-axis at anywhere but 0, you have a constant. A good example of a relationship for that would be my Southern California water bill. If I pay $50 a month standing charge plus I don't know, 20 cents a cubic foot of water, there is no way in the world, if I use 0 water in 1 month, I get 0 cost, 0 bill. So if that y-axis was my cost of my water bill, it would always be, let's say, $50. It would never be zero because I have the standing charge. So let's get back to the data. If I look at let's just do this, it's worth talking about for a while. Let's grab these two and plot them. So let's have a look. Insert chart, scatter. Okay, that's what it looks like. Now if I go to design, add a chart element, let's add a trend line, let's add a linear trend line. Well, there it is, tiny thing. If I can, okay, I can get that. I'm going to change the color so I can see it. Blah blah blah. Okay, now see that trend line there? It's apparent to me that that's going to run through the origin. So although we've got a relationship, I like to stretch these out. It looks like we've got a better relationship than we actually have. So if I stretch that out, it's clear that our relationship between the long-term moving averages scored, past and what's likely to be scored in the game, runs through the origin. So let's just delete that. So that is the reason that we went for no constant. Okay, having said that, what's our result? Now this is interesting. We always take the adjusted R square, we always check our p-value is lower than 0.05, and so the first very simple relationship we've established is predicted FanDuel points equals 0.965 times the moving average, the long-term moving average, and this value here is, of course, the adjusted R squared can be from 0 to 1 or 0% to 100%. The higher the better, and it's telling us that the X data information we've put in, if you like, has got 91% of the truth towards predicting a valid outcome. That's pretty high, and that's why both FanDuel and DraftKings give you the averages, the past average points, fantasy points scored, because they do have some intrinsic value. So let's say that's our datum. That's what any mathematical optimizer is using. So this is hitter 1. We now need to improve on that by grabbing some other stuff. Well, based on our very quick analysis of how the FanDuel points are awarded, it seems to me that the more points the team scores must correlate with a higher fantasy point score. So let's go, once again, we can only use stuff that we know prior to the match being played, and what we do know is we have lots of Vegas odds parameters in the function. So I'm going to take the Vegas team score, which simply correlates to what the, let's call it smart money, thinks is going to happen in the match. So if I tack that one on, now I'm going to run another regression analysis. All I need to do is change, so we now have 2x inputs. I'll run that, everything else is the same. So our adjusted R squared is now, let's highlight that, 0.97. So let's call that H2. We've gone from 0.91 to 0.97. So Our new formula would be predicted points equals 0.347 times the 30-day moving average plus 1.42 times the Vegas odds team score. So in theory we've pulled ahead of the normal mathematical optimizers by adding that extra bit of information. Now there's many ways we can increase on the performance of this as well. Let's just look at another good one is I like is the ballpark coefficient. This is basically, you can read through that at your leisure, but basically what it means is it's a mathematical representation of how easy or otherwise it is to score runs at a particular ballpark. So let's go back to the data. Where are we? Hitters. Let's move along here, and park coefficient. Once again the note says, oh no, pitcher, sorry. Park coefficient corresponds to MLB player coefficient. That's wrong. Okay, I got to change that. MLB, I think it's park coefficient. Have to change that. That wasn't very clever, was it? Alright, so let's take that. Let's take the park coefficient and we will put it in here, and now see if that improves our overall truth level. So that means I've got to change this. We now have 3x arguments. Put that in. Hit the button again. That didn't set the world on fire, did it? Let's have a look. So we got a. This is H3. 9775 against 97. Okay, 5. So it was in the right direction, but we're starting to squeeze up against the upper limits. Some of these you'll be down the 50s and 60s as far as adjusted R squares are concerned. So okay, it does add to the value. I'm not going to go all the way here because I have to limit the length of this video, but we could do other things like, for example, home or away. Let me just show you how I do that. Okay, what is it? Hitters. So that's a special case. Home or away comes across as string data. Comes across as H or A. So I've got to do something about that. HA. The way I do that is I put equals if the adjacent cell equals H, then let's call home, because home is better, 1, else minus 1. Okay, let's just copy that down. So now the home here is still minus 1. There is a problem with that. Let me explain it. If I just find out using the length how many characters are in there, we see there's 2. Clearly you can only see 1. So what's happening is some invisible characters are coming down from the SQL Server database. So what we need to do is we need to modify this slightly. Just put left P3. We just want the leftmost character. And of course, if this doesn't work, I'm going to try right. So let's drag that down. Okay, so it's got a trailing character. That now works. Let me just go down to here, put that there. Now let's copy this down, paste it. Now because this has an if statement which is relative, I'm going to copy that. When I come over here, I'm going to purely paste the value. Okay, so now let's run this again and see if that adds anything to the overall effectiveness of the formula. Once again, let's change that. We now have 4 components on our X side. Hit that, and we're now at 0.9777. What were we before? 0.977. Okay, we've added a little bit, you know. For sake of brevity, I'm going to get rid of that, and I'm going to say that we already have our formula, and it's this one. So, okay, and of course there's many other fields you could put in, mix and match. Okay, let's start with the pictures now. Same routine, we'll take, oops, let's make a bit more space there. Try and hurry this one along by keeping it simple. Bearing in mind this is really just an exercise in demoing how to use it. So let's see where we start. So the file will give us the basic data file from FanDuel, will give us the long-term moving average. So we'll run a regression analysis on that straight off the bat to see what we're looking at. Okay. Alright, so that gets us, I guess, 89% of the way there. Let's call that P1. So let's see, I'm just going to do one quick move on a very powerful function. Let's look in here. Where is it? Back. Okay, function help. The one I'm going to use is pitch and match. You can, as I say, read this at your leisure, but it's basically an indication of the relative strength of the lineup that the pitcher is against. So I'm going to go straight in and use that. So let's go right over here, pitcher match, and once again you'd have seen a directive to the help file there. Okay, right, now, so moving right along, let's try now. We've only got 2 factors here. And okay, that's put us up to, let's call that P2, and we are now at 95.3%. You know, I'm going to say that that's a sufficient advance over the 89s, put us up like 6%. So I'm going to say, for the purpose of this demonstration, our pitcher's predicted fantasy points is 0.468 times the long-term moving average plus 16.3 times the pitcher match coefficient. So that being said, we'll now move on to entering that into the workbook. Okay, so basically our linear regressions have produced 2 formulas. Predicted fantasy points for the hitter is 0.308 times the 30-game moving average plus 0.896 times the Vegas odds predicted team score plus 2.552 times the Park coefficient. Okay, I don't know why that. Oh, that's a different time. That's supposed to be times. Okay, and the picture is fantasy points equals 0.468 times the 30 game moving average plus 16.3 times the pitcher match. And the pitcher match, of course, we can read about and is an indication of the relative strength of the opposing hitters. Okay, just as a very quick digression, this is what it would look like when we enter. This is a linear regression, or it might even be genetic algorithm I'm running. I can't remember the source of that one. That's what it's going to look like when we program it in. But to give you just a sneak preview of ultimately where we're going with this, this machine learning, if you look at this, the bets for today are number one, the straight file optimization from the FanDuel file. Bet 2, the DFS crowdsourced optimization. BotMave, that's just a regression analysis, so that's the regression analysis. And the final one will be genetic. So for today we've got a matrix of bets, all of which offer a different picture, I think. Quite often that doesn't happen, but today there's 1, 2, 3, there's 4 different pictures. So that's where we're basically going with this. So now let's go back to a clean copy. Alright, let me just pull. Okay, with a clean copy, let's go into the estimator, and that's where the final score will go. So actually, let's just before I start, let's just grab, firstly, let's do this one. I'm going to grab the formula. It's just put it down here for ease of use. Okay, so we need a, first of all, let's see what the position is, because ultimately we're going to have an if statement deciding whether it's a hit, the person is a hitter or a pitcher. So equals, and before we go, I'll just, this is player fact, so we go, there it is, MLB player fact. The argument, the first argument is player's name, second one is the position, POS, which is a string, so position equals MLB underscore player fact. First one is the player's name, and the second one is POS. So there we go, so it comes out as C there. Now let's put here, so we're doing the hitter first, aren't we? So hitter result, and sometimes I find it easier to color code. So that's one of the results we're going to need. Okay, 30 game moving average. So this one equals MLB moving average fantasy points for that player, and this is going to be 30. It's just a number because that's a value, it's not a string. Okay. Vegas team score. So Vegas team score. You know, we know it's obviously team score because we don't know what the, we know it's the Vegas thing. So let's look in here. Let's go to Vegas odds. Okay, Vegas odds. The argument is team score. So MLB Vegas odds. It's all written down there for you to read. So equals MLB Vegas odds, and the first argument is the player's name. The second argument is, what was it, team score. Okay, so now we have the team score. And incidentally, of course, if it's not already apparent, the API knows who AJ Ellis is. They know who he's playing today. Just wait for the dogs to quieten down there. And so the API knows where the player's playing and everything. So let's put in here park. That's the park coefficient. So equals MLB park coefficient. This only has one argument, player's name. So that's what that is. Once again, look at the function help if you want a more detailed description. So I've got everything I need data wise in here. So hitter result equals, I'm doing it up here in the equation bar, 0.308 times 30 game moving average, right? So that plus 0.896 times Vegas team score plus 2.552 times park coefficient. Enter. Right, so that's the prediction for him. Okay, so that's the hitter all wired up. Let's go back and grab our pitcher formula. Okay, so let's put pitcher result. So let's make that green. Of course, these colours are purely voluntary. I just seem to like them because then I know what to link to the final. So what do I need? I actually can use 30 game moving average from there, so I won't bother to do that. So all I need is the pitcher match. Once again, I love this one because the API does a lot of work in the background. Let's just discuss it when we go. What it basically does is it assumes there's a correlation between the FanDuel salary and the value of the player, which is not a bad assumption. So it adds up actually no, that's the different one. Yeah, pitcher match adds up the 30 game moving average for all the 9 hitters. It doesn't do it on salary, that's another one. It basically adds up all the fantasy points in the lineup, compares it mathematically to the average fantasy point value of the lineup, from 1 to 9 or 1 to 8 today, and that gives you a relative feeling for the strength of the matchup that the pitcher has. So, obviously the more fantasy points, the better you would think the hitters are. So, the syntax is MLB pitcher match. Let's throw that in. So that equals MLB pitcher match for this guy. Now, of course, it just comes out as unity if the guy isn't a pitcher, so he's not a pitcher, and that will only trigger when we actually have a pitcher. It will only go off of 1. So let's do this then. For the pitcher result equals, and what we go up to the bar here, equals 0.468 times the 30 game moving average. We've already got that once, so we'll steal it from there. Okay, did I just do some? Alright, so yeah, sorry about that. Plus, so we've got 0.468 times the 30 game moving average, which is F4, plus 16.311 times the pitcher match. So if he were a pitcher, which he's not, it would come out as that. So now this is where we put the conditional statement. This will be our final result. Actually, to be consistent, I should have that in green. So we've got the final result we want to take. If he was a hitter, that's the result. If he was a pitcher, that's the result. So equals if, now the test is if that cell is equal to P, then he's a pitcher. I want to take that result. Else, I want to take that result. So, alright, it rounds up on that one. So, now what we need to do is get rid of that, and we need to test it now. Okay, so the final move now is to wire it up to the live fantasy points column. So we wire that up, and once again, I know I say this quite often, but we have to make that connection because the genetic algorithm, the crowdsourced predictions all dump into this line. I'll give you an example. See how I just put that formula in, equals C4? If I ask for the crowdsourced predictions now, okay, I just downloaded them. You see that's now just 8, because AJ Ellis, his crowdsourced prediction is 8. Well, that's interesting. And our little run here has produced 8.1. Well. So this often gets overwritten. So before we use this calculator here, we always make sure our final results in that column, and then we connect it over. So anyway, that's what we want. That's our deal. Let's just give it a test. So I'll flip that to the top 20, fill and recalculate. Light's gone green again. So let's just check. We've got a, that's interesting. So this guy, we don't even know who he is. Alright, I've got a picture here. So let's just check that the picture calculation was 27.6. It went over to our final. It didn't take the hitter. Everything else is out of this column. Okay, so I'm going to say that that's a good deal, and I'm going to flip this over to all, and now I'm going to recalculate everything. Are you sure you want to do this? I surely do. Okay, so now you don't touch anything, but if you look at the function data, we've got it for 8 minutes past 3. It's now 3:48. Okay, predictions. Would you like them transferred to the solver? Yes. Okay. Transfer complete. Please remember to run the solver filters again. Okay. Yeah, I know what's wrong with this. I didn't load today's file, and this is operating on today's, so I can. This is what I do anyway. Let me just show you. And then I'd hit that, and this would be my optimization, except it isn't valid for today because the last time we used this file was a few days ago. So it's got the wrong FanDuel daily data file, but don't worry about that. That's basically the process. So we've done our first analysis, linear regression analysis for both hitter and pitcher, and we've produced predictions for the whole data file that was loaded whenever. So that is essentially how you use that. Now, this is for those who love linear regression. You will ultimately find that when we get into the next video, which is genetic algorithms, this is actually a lot easier. Once you set it up, you just keep running, and you refresh it every day by running it. So in a way, doing a basic genetic algorithm is a lot easier. Although having said that, when I do regression analysis, for example, this one would not change for, you know, maybe a couple of weeks. If it's winning, why mess with it? You'll see earlier on in the video I have a much more complex one which I'm actually running myself. So that is it. Hope you enjoyed it. The next video will cover another powerful tool, the genetic algorithm. Thank you once again for listening.